All right, so this is our last new topic before we start with our final or last test, whatever it's going to be that we'll be taking next week. All right, so on that note, we will be having a test next week. It'll be over all of Chapter 4 and this last section here, which is, so I'll write that up here, 5.1. All right, and there'll be a homework progress check over all this. All right, so this is really just solving systems of equations. All right, the system of equation is really just one or more, or sorry, more than one equation, usually with more than one variable. We are going to stick to two equations, two variables. You need two equations to solve two variables, three equations to solve three variables, and so on. Again, we'll be sticking with an x and y system with just two equations. All right, our first method we're going to solve by is with graphing. All right, it's pretty straightforward. You just graph your two systems, and we are going to also be sticking with a linear for all of our equations. All right, so we'd graph these. I'll graph this first one with black ink. The second one will be the red ink. All right, plus 3. The negative 5 over 3 will be down 5 over 3. All right, and then just connect your dots, and we have that line. All right, we graph the red one. So we can start at minus 3, over 1 up 3. We can already see where we're going to overlap there. All right, but we connect the dots, and we get that line. All right, and so then our solution, this is the part that gives us a true answer for both equations, right? X might be 6 in one of them and 4 in the other. All right, but this one, X and Y are going to work for both. The same X and Y are going to work for both, and it's always going to be written as a point. All right, and this point here is, what, 3, negative 2. All right, and so that's our solution. Another way to write that is X equals 3, Y equals negative 2, which this second way you'll probably be writing more often than not when we're solving by other methods. Because solving by graphing is great, but it's not the most efficient way to solve. All right. The next method is going to be solving by, as a note, we call this a consistent. I don't really care too much about this, but it is what the book uses. This is a consistent system. All right, we'll see an inconsistent system here in a second. All right, solving by substitution. All right, we're going to do a couple examples here. This first one is going to end up being an inconsistent system, but let's see why. All right, substitution is really just, another way to say this is plug in. All right, so we're going to solve one equation for one variable, substitute that in to the other equation. All right, so with this first one, we can solve and get x by itself by adding that 3y to both sides. All right, so x is actually equal to 3y plus 7. All right, now we're going to substitute or plug that in to our x variable in this second equation. All right, you always go to the other equation, which gives us the equation 2 times 3y plus 7. Oops, let me clean that up. Minus 6y equals 12. All right, then now you just have a linear equation that you can solve. It's only as one variable. Once you have one variable, you can solve it. Distribute your 2. We get 6y plus 14 minus 6y equals 12, which gives me 14 equals 12. And this is obviously a false statement, which tells me no solution. All right, when there's no solution, this is what we call the inconsistent system. All right, if you check in the answer key, I've done a quick example of a substitution that actually has a solution, but just for time, I'm going to save that for that answer key there, so you can go and check that. All right, again, what you would normally do is if you get x, or in this case, you get y equals, say, 7, you take that 7, you plug it back into your x equation. All right, but again, check that answer key to see that extension there. Our last method is solving by elimination. This is also sometimes called solving by addition. It's not the most commonly used. Well, I mean, it's very commonly used. I don't prefer it very often. I like the substitution the best in graphing if they're graphable. But this is nice especially if you have an equation like this one over here, because it's not going to be easy to substitute with this one. This one's just easier to get to an elimination. All right, with elimination, what you're trying to do is get one of the variables eliminated. Right, that's what we call it, elimination, by lining it up as the opposite of the other equation. Right, so here we have a 2x and a negative 5x. I want those to have the same coefficients. Actually, I want them to have opposite coefficients. So what I'm going to do is I'm going to multiply that entire first equation by 5, because they're already opposites. Multiply this entire second one by 2, and that means I can rewrite my system as, let me undo that, 10x minus 30y is equal to 60. The second system, or the second equation within the system, would be negative 10x plus 30y equals negative 60. All right, and this is where we call it addition sometimes, is we're just going to add these two together. We just combine like terms, right? 10x plus negative 10x, so it actually cancels out and we get 0. This one also cancels, and this one actually also cancels as well. We end up with 0 equals 0, which is something that's always true. And so this has infinitely many solutions. All right, and again, if you go back to that, what we call these, this is sometimes called a consistent dependent system. Again, I'm not going to be concerned about that, but my math lab does ask questions like that sometimes. All right, the main thing though is to notice it has infinitely many solutions. So on the rest of this packet, there are a bunch of practice problems to try. This one you'll notice is the same as before. The one above this one here is also the same as this one, so not too many there, but down here, these 4, try these. Think about what the most efficient way to solve these would be, right? Some of them might be better to graph because, like this one, because it's already set up in a y equals mx plus b in that slope-intercept form. This one may be better for substitution or the elimination. This one looks like y is already by itself, so it could be a good substitution. All right, so it's really whatever one you want. I don't care which method you use. On the homework and on the progress checks, it will say solve by this method, but there's really no way for me to make sure you're doing it by a specific method. So my suggestion is to get really good with one of them, learn that, and be okay. All right.